Welcome back to the Algebra 2 series, where today we're going to develop from the definition of the parabola some algebraic work. And we see here in a plane, the set of points that are equidistant to a line and a point not on the line is the given definition. Here's our point. We'll call this the focus. And the focus is going to be the central location of the definition of that fixed point, and I like to choose that vertex value, the one right in between, and then of course we saw in class how we like to make this square to the left and right or to the sides of the focus, and then create for ourselves a double box. Those are supposed to be square, by the way, and then put those in, which turn out to be the endpoints of the lattice rectum on both sides, endpoint of the lattice rectum on this side. That lattice rectum, the segment going through the focus. And then, of course, we have our parabola that we trace out here, given our vertex at the bottom there. Now, one of the points that we worked through was that we're going to assign this length to be A. And if that's the case, then the opposite direction is also A, and that makes this length out here 2A, and of course the length the other way 2A, which gives us a lattice rectum length of 4A. And of course that's going to come up in our equations as we go along. So continuing on, let's take a look at this second picture. This is a vertical parabola, and it has our vertex right at the origin. So that should make things pretty snappy here. We're going to try to show that this equation is equal to x squared equals 4ay. And that's going to be something we need to work through based on the definition. We're taking the definition from geometry, and we're actually going to work this out in the Cartesian plane. Well, if it's true that the distance from any point on our parabola to the focus over here is equal to the distance from that same point down to our directrix over here, and that's what we call that line, the directrix, then we could write d1 over here and a d2 right here, and see then that the two distances are equal. So d1 equals d2 is what we're going to actually work out algebraically. Before we do that, we have to know what these ordered pairs are, and this ordered pair, and the focus, of course, that ordered pair. In this case, I think the ordered pair for the focus would be the easy one. If the vertex is 0, 0, and we're going up a units, then this would be 0, comma, a for the focus. And then in order to find that point over here by the directrix, we would end up writing the same x value as it is up on the point on the graph, and then I guess it would be negative a because we have to go down a units. So those are our 3 points. We're going to have 3 points and 2 distances, and we'll work these out. Of course, when we do the radical for these, we'll take the radicals off both sides in just a minute. But let me move this up here for a second here. There we go. Let's begin with D1. D1 is going from the point xy over to the focus. So x minus 0 squared, and then plus y minus a squared. And that's going to be our first point. And then the second point down here, our first distance, excuse me, the second distance will be the vertical one. So that's going to be x minus x squared and y minus negative a squared. So that's a bit of an odd value. Well, a couple of things to point out here. First of all, x minus x is going to be 0. That will drop out. And also these radicals will drop out because we'll square both sides away. We also come up with just an x right here squaring. So x squared plus y minus a squared is equal to simply y plus a squared. Now we're kind of thinking ahead a bit. We're going to see where this y term on this side and the y term on the other side there, as we square them out, we should end up with some cancellations going on there. So let me write this all out. This is going to be y squared minus 2ay, that's the middle term for that squared binomial, plus a squared is equal to y squared plus 2ay plus a squared. And here you see those values dropping out here. This one, this one, this one, and this one dropping out. And that gives us a nice solution here, x squared. And I'm going to take this guy to the other side to be with his friend. That's 4ay. And oh golly, look, we just got it. So we got what we were looking for, the equation of that simple parabola. We're going to do one more of these real quick, and that, well, I say real quick, but this is a horizontal parabola, and it has a vertex here at HK. So if you look at HK, that's not at the origin anymore, and our focus is going to be a little bit more complex. Instead of being something simple like 0a was in the last example, this one is going to be H plus A, comma, and the same height as the vertex K. And our point xy is here, and now we've got to find this guy in order to do the same procedure. We'll have the same y values. I'm going to cheat here and do the y first. The x value will be from the vertex, we're going to go straight across here, and that would be h minus a. So I have my two distances. Let's call this my distance 1 and this my distance 2. And that looks pretty nasty. Let's give it a try though. D1 equals D2. So D1 equals D2. And again, we do the same thing we did before. And we're going to have these, oh boy, it looks like I'm in a bit of a spot here. Okay, so let me write these out. D1 will be from the point xy up to the focus. So it would be x minus h plus a squared plus y minus k squared. Oh boy, that was a good one. And then straight across is going to give me x minus h minus a squared. And then the y minus y is just going to give me 0. So I'll just drop that right there. Once again, we notice that our radicals will drop out, these two. So those are going to disappear. And the rest looks pretty ugly. Let me write it out here for you. This is x minus h plus a quantity squared plus y minus k quantity squared. And I don't see anything canceling with this one, so I'll just leave that alone. But this other one, it looks like plenty of things will cancel. This is h minus a squared. Notice that the x's will eventually cancel as I square this out. Some other things will cancel. So we'll actually work this out entirely. I'm going to square this binomial. That'll produce x squared minus 2x times h plus a, and then minus h plus a squared. Carrying down my other portion here, y minus k squared. On the right-hand side, that's going to be x squared minus 2x quantity h minus a plus h minus a quantity squared. And here we see an x squared that drops out entirely. I don't see a whole lot other things dropping out until I distribute. So we'll do a couple more steps here. First, I'll distribute this 2x inside of my quantity. So negative 2x h minus 2ax. And I'm going to square this out. H squared plus 2ah plus a squared plus y minus k squared. And that produces then on the other side negative 2xh plus 2ax plus h squared minus 2ah plus a squared. Whew, that was a lot of work. All right. Working these out, I'm going to see some things going on here with, let me Move this up a bit. Okay. Um, did I do that? Oh, I think I believe I have a little sign error right back here. I think this is supposed to be a plus. My fault on that. That's a plus right there because I'm squaring this binomial, so the middle term is negative, but the outside terms are positive there. Sorry about that. So that makes a plus there. So we'll notice plenty things canceling here. This is going to be the first item right here that will cancel. And notice that the h squared will cancel and the a squared will cancel. And before I combine, let me write this out again. It's going to be negative 2ax plus y minus k squared is equal to 2ax minus 2ah. Ah, gosh, I feel like I missed something. Oh, here it is. Oh boy, I'm really making a mess of this one. Let me erase this. Sorry about that. I missed a spot here. I missed this guy right here. So let me rewrite that. Negative 2ax plus 2ah. I'm being hasty here. And then y minus k squared. Okay, now we're on track. This is 2ax and then minus 2ah. Okay, minus 2ah. Very good. Okay. Whew, that's pretty hard stuff. So all this guy, that'll go to the other side. So y minus k is squared. And as we add the two together, we get 4ax minus 4ah, or as we see here, y minus k squared is equal to 4a quantity x minus h. And the interesting part about this is that you'll notice the answer comes out to be very similar to what we got in the last problem. If we go back one page and you look at what we ended up with right down here, we ended up with the same thing, that 4a coming out front. In this case, the x and the y, because the vertex was at the origin, they just have a 0 attached to them. Whereas in this problem, we end up with the h and the k as our vertex value. So we see now a summary, then this is going to be a horizontal parabola, and it opens to the right. And the second half of this presentation, I will continue with some graphing problems and then working out the algebra from there. So I'm going to stop here.